Welcome back to our science series, where we explore the building block of chemistry step by step. In our previous episode, we explored atomic structure and how atoms form chemical bonds. Today, we move forward into one of the most exciting and dynamic areas of chemistry, chemical reactions, the process that transforms substances and literally power the world around us. Chemical reactions are all around us and within us. Every time we breathe, cells in our bodies use oxygen in a chemical reaction to release energy from food. When you light a candle, rust from an iron, or your phone battery charge, you are witnessing different types of reactions. But what exactly is a chemical reaction? In simple terms, it is a process where one or more substances called reactants are transformed into new substances known as products. During this process, chemical bonds are broken and new ones are formed, which involves the transfer or rearrangement of energy. One of the most fundamental ideas to understand chemical reaction is the law of conservation of mass, which states that matter is neither created nor destroyed in a reaction. This means that the total number of atoms in the reactants must equal to the total number of atoms in the products. We call it balanced equation. That's why chemical reaction must always be balanced, as I said. They represent real molecular changes happening in nature. There are several types of chemical reactions, each with unique characteristics. Synthesis reactions combine simple substances to form more complex compounds, like when hydrogen reacts with oxygen to form water. In contrast, decomposition reactions break down compounds into simpler substances, such as the breakdown of hydrogen peroxide into water and oxygen gas. Single replacement reaction occur when one element replaces another in a compound and oxygen gas. While double replacement reactions involve the exchange of ions between two compounds. Finally, combustion reactions release large amounts of energy in the form of heat and light, which is why they're used in engines and power generation. The energy changes in chemical reactions are also central to understand how reactions work. Chemical reactions either absorb or release energy. When energy is released into the surrounding, we call it an exothermic reaction. Burning fuels, like in a car engine or stove, it's a classic exothermic process. On the other hand, reactions that absorb energy from the surrounding are endothermic, like photosynthesis. In this process, plants absorb energy from sunlight to convert carbon dioxide and water into glucose and oxygen, storing that energy in chemical bonds. These energy changes are directly related to bond energies, because breaking bonds requires energy, while forming bond releases energy. For chemical reaction to occur, particles must collide with enough energy and proper orientations. This idea is explained by the collision theory, which tells us that not every collision between particles results in a reaction. The reactants must have enough activation energy, the minimum energy required to start the reaction. If this energy barrier is too high, the reaction will be slow or may not happen at all. That's why heat, light, or even electricity is sometimes needed to trigger reactions. However, reactions can also be sped up using catalysts, substances that lower activation energy without being used up in the process. Enzymes in our bodies are biological catalysts that control reactions necessary for life, from digestion to muscle movements. Chemical reactions also vary in speed, and the rate of reactions depend on several factors such as temperature, concentration, surface area, and the presence of a catalyst. Higher temperature causes particles to move faster and collide more often, increasing the reaction rate. Increased concentration means more particles are available to collide. Finally, powered substances react faster than large chunks due to increased surface area. Catalysts speed up reactions by helping particles react more efficiently. These factors explain why food spoiled faster in warm weather and why powdered medications dissolve more quickly in the body. Chemical reactions are not just important in laboratories, they shape our world. The powered batteries in electric cars allow plants to convert sunlight into energy, break down pollutions in the environment, and even help build new materials like plastics and medicines. Understanding how reactions work allows scientists and engineers to design cleaner energy systems, more effective medical treatments, and innovative technologies for the future. In summary, chemical reactions are transformations driven by the rearrangement of atoms and energy. They are governed by the fundamental principles such as conservation of mass, energy changes in bonds, and collision theory. Whether slow and silent like rusting iron or explosive and powerful like fireworks, chemical reactions are the driving force behind physical change, life process, and modern technology. Thank you for joining me in this episode. In our next season, we will explore reactions rates in more detail and uncover the mathematical side of chemistry, how we measure, predict, and control chemical change. Stay curious, and I will see you next time.